In this chapter, we are going to learn about defining methods for the class and accessing or referencing the class methods, writing the functions for operator overloading, similarly the writing member function, which is a constructor for a class, and also we learn about type based dispatch and the polymorphic features of Python. As we know, Python is an object-oriented programming language. It supports three pillars: encapsulation and abstraction, inheritance, and polymorphism. As part of the encapsulation, the Python, which defines the class, has two different members. One member is a attribute that is also called as a data member, and the second called the member function or method. And every program, object oriented program, will have one or more classes defined in it with the attributes and method definitions. And computation within the program normally expressed in terms of operations on the objects, and the objects that we create or instantiate from the class normally represent things in the real world, and thereby the methods which are defined within the class corresponds to the ways the things in the real world interact. As an example, to illustrate these three characteristics of object-oriented language, let us take up the time class, where class time corresponds to the way the people record the time of day, that is hours, minutes, and seconds. And the functions like add time or increment, which are defined, correspond to kinds of things that people do with these times. Now let us understand how to define a function in Python. A method is a function that is associated with a particular class. Normally method is also called as a member function because it is a member of a class. Methods are semantically same as function, but there are two syntactic differences. One is methods are always defined inside a class definition in Python in order to establish the relationship between the class and the method. And second is a syntax to invoke a method, to reference a method, is different from a function. That the syntax that we use normally syntax that we use to access a method involves the class instance or object. Let's take up the example. To define a function called print, wherein we want to print a time in terms of hours, minutes, and seconds, what we have to do is we had written a function in the previous chapter print time, which is a function. Now in order to make that as a member, we have to define that function inside the class. And now this class definition goes like this: class time, then we write a function. Now it becomes a member or a member function or a method. Now it is a method because it is a part of a class having one line as a body of this method. Just note the indentation. We have an indentation for a function as well as the function body. How to call the members or member functions or methods? There are two ways. The first is a simple syntax. We can use a class name dot method with the object parameter. This is also valid because time is a class object. We can use that class object to invoke a method where the object is a parameter for the print time. And the second is you can note that this syntax uses a dot notation. This is the name of the class and print time is a method, and the start is the object that is passed to a parameter. And the second method is very concise way of calling a function. Normally it is called as a method syntax. It goes like this: it starts with the object dot the function, and we are not going to specify the object as a parameter here. The print function takes one parameter, object parameter, but here we have an implicit object. This implicit object is also called as a subject. This represents the object on which the method is invoked. The start is the subject. It is an object in which the method print time is invoked. That's why we call it as a method syntax. Always we use a subject object object to invoke the method. And remember, inside the function print time we found one parameter, and here since this subject is the object in which the method is being invoked, this subject becomes the first parameter. And you have to always remember the subject. If you have a method involving number of objects and other parameter, subject will be the first parameter in the method definition. So by convention, as I said, the first parameter of a method is also called as a self. Self refers to the object on which the method is invoked, self. Okay, and always we have to specify this parameter self to represent the subject. So let us rewrite this function print time. Define print time self, and the body remains same. Similarly, we can write other two functions with this subject. One is increment. This is the object on which this method is being invoked, self, comma second. If you see a simple function increment, we had only one parameter. Now we have two parameters, seconds as well as self, and we convert this seconds into the time into integers, and then we convert the the seconds and the seconds received from the time, and then we return the new object, time object, by using into time function. These two functions we had defined in the chapter 2, converting time into an integer quantity and again converting the integer back onto the time object. And also we can represent the time to integer and integer to time again in this pattern. We have a time to integer is a self the object time and so on. This is how we can access the functions. We can print the object time using start.print time, and end time we can increment start.increment with some seconds, and we can even print the time using end.print time. Here observe that the subject start gets assigned to the first parameter self in the print time as well as in the increment. This is a second parameter if you see the definition of the increment. Let us understand two types of arguments. One is a positional argument. What is this positional argument? Positional argument is a parameter found in the method call which has a value but no parameter name. Parameter name normally refers to the formal argument. And we have one more argument called keyword argument. Keyword argument is a argument or a parameter found in the method call where the argument has a name as well as value, and we use a assignment operator that is equal between name and value. Let us understand these two types of arguments with one simple example. Let's consider this function call sketch with first argument, and this is a second argument, and this is a third argument. This argument and the second argument, these are positional arguments. Whatever the parameter in the formal definition of the function receives this parameter, and no name, formal parameter name is specified here, you can see. But this is keyword parameter where formal argument name is specified along with the value. And always remember, do not intermix positional and keyword parameters. Always keep keyword parameters or write the keyword parameters only after positional parameters, both in the function call as well as in the function, that's a method call, as well as in the method definition. Let us take up one more example, the function is after. This function will return true if the first time object is greater than the second time object, that is other. This function is very quite simple. Just we convert the time into integer and we return true or false by through the comparison of these integer values. The above example is more complicated because it takes two time objects as parameters. There is one is a subject, there's an object on which this function is being called, and second one is explicit object, that is here the name is other. And this is, in this case, it is conventional to name the first parameter self. It is a convention, and even we can change, and we have used the name for the second object as other. And in order to use this method, we have to write whether end is after start. This is a subject. We are calling this function on the time end, and this is the explicit argument. This is a argument which refers to the positional argument, which is substituted to parameter other. Now we will take up the two important methods. One is called init method and second is a str method. What is this init method? Init method is a abbreviation of initialization. Is a special method that gets invoked when an object is instantiated. It is nothing but a constructor in C++, Java or C#. Its full name is double underscore init double underscore. We'll take up one example to illustrate this, the use of init. So let us define init for the time object to create the time object with default value 0, 0, 0. So we define a method double underscore init double underscore. This is a subject, self object, and we have a 3 default parameters. What is this default parameters? If a function method call doesn't supply the argument, these default values are considered. The body of this method will assign these default parameters to the attribute hour, minute and second respectively. And it is common for the parameters of init to have same names as attributes. Even we can change the parameters here. It is possible, but it is the common thing that we write the same names for the parameter as that of attributes. The statement in the previous slide, self dot hour equal to hour, stores the value of the parameter hour as an attribute of self. And I said all these three parameters are optional. If you call just t is equal to time with no arguments, then hour, minute and second gets a 0. If we provide argument like this, then first parameter, this hour, gets the value 9, and the result of this is we get 900. And if you provide two arguments, they override hour and minute. Hour gets the value as well as minute gets, and the second default. And if we provide all the three arguments, all three attribute, the default arguments are overridden with the actual values that are present in the method call. The second important method is double underscore str double underscore method. It's a special method like a constructor init, and it is used to return a string representation of an object. And it is the programmer who defines the string representation of an object. It is not like a C# toString function which returns a string representation where it has got a built-in definition, as well as programmer can redefine it, override it. But here the string representation has to be defined by the programmer. We'll take up the same class time, and we display the time in terms of hours, minutes and seconds. So we define a method with the def double underscore str double underscore with the subject. Self is object, subject, and this returns a string representation of this object, that is hour, then minute and seconds, with the 2-digit for each of these values. And when you print the object, you can invoke this str method like this, print time. So this becomes a self object, explicit object, and we get the result 9:45:00. Python also supports operator overloading. By defining special methods, we can specify the behavior of the built-in operator on programmer defined types like class objects. Let us take up one example. We try to define a method add with double underscore add double underscore to add 2 time objects, so that we can use plus operator on time objects. We need to add this special method inside the class time like this, define def double underscore add self subject and the second object, and we know the body of this add. We convert the time into integer, both the objects, and then again we convert the total seconds to a time object, and a new object will be returned. And this is how we can call this add method. We create an object start, then we create another object duration, and now we can use a plus operator to add 2 objects, print start plus duration. This plus automatically makes a call to double underscore add double underscore method, and this method returns the time object, which will be printed. Print will get the new object, and that is printed by the print time. When you apply the plus operator to time objects, as I said, it invokes double underscore and double underscore method. And similarly, when you print the result, Python invokes underscore double underscore str double underscore automatically. So there is a lot of things happening behind the scenes, and the changing the behavior of an operator so that it works with programmer defined types is called formally as operator overloading. It means that the programmer can add more meaning to the existing operators by defining the special functions, so that the operator can be applied on to the programmer defined types like classes. Note that every operator in Python, for every operator in Python, there is a corresponding special method defined. For example, for add it is double underscore add double underscore, for subtract double underscore sub double underscore, and so on, for multiplication and division and even other operators. Type-based dispatch. What is this? Type-based dispatch is a mechanism which selects the suitable method at runtime for execution based on the type of the parameter or the argument. Let us understand this concept by taking the time object and the two methods, related methods called add time or increment. We define a class time with the overloaded method for operator add, and we want to add two objects if two parameter represents the objects. Otherwise we want to add the seconds, we want to add seconds in order to increment the time. This can be done by checking the type of the object. Assume that we want to check the type of the object other, and based on that, this, and the self is the subject and this has to be an object. We want to check the second argument whether it is an object or a number. If it is an object, we make a call to add time method, and if this other is a number other than object of type time, then we make a call to an increment. And to check whether the parameter is of type time, we have a built-in function called isInstance. If this parameter is an instance of time, then it returns true. It means we are going to add two time objects. One is a implicit object, that is a self, and second is the explicit object. Otherwise we make a call to function increment, which takes the argument other, which represents the number, and we can have other two functions. We have already defined this add time by using a subject and other object, and also we have to define this increment as part of the class object. And this selection of a method for the execution at runtime based on the type of parameter or the object parameter is called a type based dispatch. In the previous example we saw the based on the type of parameter other, the add time is invoked or increment is invoked. Add time is invoked when other is of type time. Otherwise, if it represents the number, if it is other than object time, then we are going to make a call to increment, and this happens at runtime. The method is chosen for execution based on the type of the parameter at runtime. That's why this name is called, the concept is called type based method dispatch. So here is an example. We can use the print start plus duration. Here two objects are added using a type based dispatch. Here add is being used, method double underscore add double underscore, and in this case increment method is being executed, because this is not an object of a class time. This duration is an object of a time class time. Remember, the implementation of this type of addition with the operator overloading onto the programmer defined types is not commutative. If the integer is the first operand, then we will get the runtime error saying unsupported operand time for plus. And how to manage such a type of code? We have a special method called radd, which stands for right side add. Why this method is being defined? If we see the previous function call, where first object is actually should be a subject, should be a self object, but we represented the number is not an object. That's why we found that the runtime displaying or resulting in an error. If we use, instead of add, if we use radd, the right side parameter is considered as an subject if the first parameter is not an object. Here is the function definition. Class time, instead of add, just write radd self other, and ultimately internally you can write self dot underscore add underscore other, and we need to have a definition for this. Here the self dot add under double underscore add, we need to have a definition for this add, and this is a one additional function definition. Now we can write print the number plus start, wherein the start is considered as a subject and then this is considered as a other. Right side add. The type based dispatch is useful when it is necessary, but it is not always necessary. That means that it is not necessary that you have to use a type based dispatch. You can avoid this type based dispatch by writing a function that works on different types, and the writing the functions which works on multiple types is called the polymorphic functions. Let us consider one such polymorphic function called histogram, which counts the number of items present in either list or a dictionary or a string, letters in a string, and so on. Let us define a function histogram which takes one item s, and we have seen this the body of this function, which gives me a frequency counter histogram of the element, and observe that this histogram function will work as long as s has the items which are hashable, because we are using a dictionary which works on the principle of hashing. If we call this function histogram for the list of strings, we get this result. Similarly, this function can be used for, let us say, list s with only integer values, or even characters or other types, even dictionaries or tuples. So the functions that work on several types are called, in a programming terminology, polymorphic function. And this is one type of function polymorphism, where a function works on different types. And the one benefit of this writing polymorphic function is the code reuse. This function polymorphism facilitate the code reuse. We don't have to write the code separately to handle different types we can have only one polymorphic function, and that itself handles variety of function, thereby it reduces the application code. If you see, the built-in function sum, which adds the elements of the sequence, works as long as the elements of the sequence support addition. For example, even if you have the sequence with floating point numbers, the sum will work. Similarly, for the integer, it works. As the time object, provide the method add, and add is the function add double underscore add double underscore, which is the function for the operator plus, overloaded operator plus. Thus, even we can use this built-in aggregate function sum to add the time objects. Let us say we have a t1, t2, t3 like this, and we can get the sum of all the three times by writing the list of object. So this is square bracket represent the list of three objects, sequence containing three objects, and we can finally we can get the sum as a total. This is one benefit of polymorphism. Remember, the Python facilitates function polymorphism, wherein programmer can define or can write polymorphic functions which takes different types of arguments. These are the few simple review questions for the self-assessment, and these exercise programs mainly deals with writing printing objects and writing constructors, and also writing a function for operator overloading, adding two complex numbers with the operator overloading concept. These are the two links for further reading. One is for the to know more about polymorphism. You can refer this. Also, to learn more about operator overloading, you can refer this link. Thank you.